Hi everyone. So today we will be discussing the topic of dimensionless groups, and the idea behind this video is to really give you a flavor of how we can use the topics we are learning in class in real life research problems. So the problem that I have written down is actually a problem that can have applications in inkjet printing, in emulsion technology, which is commonly used in cosmetic industry, food industry, and so on. And hopefully this will give you a flavor of how dimensionless numbers play an important role in the applications, in real life applications. Uh, so the problem that I have written down here is, consider a droplet of diameter d. Let's say this is the circle that I have drawn here is of diameter d, and the droplet has a viscosity mu d, something that we have discussed in class, viscosity, density rho d, and this droplet is being deformed from outside by a stress tau, which is written here, and then and the surface tension between the two phases, between the droplet phase and this outer phase, is gamma. Now the question is asking us, what are the important dimensionless numbers of the system with the surface tension between the two phases is gamma. Now for this we will naturally use the Buckingham PI theorem that we have discussed in class, because we have been asked to find the important dimensionless number, and we have used Buckingham PI theorem in Rayleigh analysis in class, and that is what we will refer to now. So just to recall, the Buckingham PI theorem states that we will have n dimensionless number, capital N, where n is m minus n, where small m is the number of physical quantities and small n is the number of dimensions. So what are the physical quantities that have been given to us here? So let us just write them down. So we have been given 5 physical quantities here. So physical quantity, the physical quantities that we have been given is diameter, viscosity, density, stress, and surface tension. And what are the units of these physical quantities and what are the dimensions? So the units of diameter would be what? It would be meters, because it's a unit of length. Of viscosity we have discussed in class, it is Pascal second. Pascal second. Of density is kg per meter cube. Of tau is pascals. And of surface tension is Newton per meter. So we have discussed all of this in class, and what will be the dimensions of this diameter of all these physical quantities? Dimensions would be of meter would be length. Of Pascal seconds, you can work it out. Basically, pascals is kg per meter second square. So actually it becomes kg per meter second, or ml minus 1 t minus 1. You can work this out. This is not very difficult to show. On density is kg per meter cube, so straightforward, ml minus 3. Then pascals again is kg per meter second square. You can sort of remember this or sort of derive this. It's not very tough to show. Or ml minus 1 t minus 2. And Newton per meter, which is Newton is kg meter per second square. So this actually becomes kg per second square, or mt minus 2. So this is what we have, and we know that we have 5 physical quantities, and what are the dimensions we have? M, L and T, or small n is equal to 3. So n is 5 minus 3 is equal to 2. So small m is 5 and small n is 3. So we'll have 2 independent dimensionless numbers which are important for this system, and we have been basically asked to find them. Now I hope that you sort of understand how we will go about this using the Rayleigh analysis, and I will go step by step in this problem. But in case you sort of do not recall from class, let us just briefly get back to what we have to do in Rayleigh analysis. So basically, to get Rayleigh analysis, we'll take 4 variables for one dimensions. We take 4 variables such that all the 4 variables somehow span all the 3 dimensions. For instance, if I choose diameter, viscosity, density and tau, or the first 4 numbers 1, 2, 3, 4, I am getting all L, M, L, T, all the three variables, and I have 4 dimensions. I have to choose 4 dimensions. And why 4 dimensions? Of 4 variables, I will talk about this. So let us take d, mu d, rho d, and tau. So I'll say d raised power of x1, mu d raised power of x2, rho d raised power of x3, and tau raised power of x4. I'll say my dimensionless number n1 is in this form. And you can ask, why do we need 4 variables? Why not 2 variables, and why not 3 variables? Basically, I'm taking 4 variables because I have 3 dimensions, and I will take 1 plus the number of dimensions I have. And why is that? Why can't I just take 3 variables? Uh, that is because if I take 3 variables, you can assume that you can always have a trivial solution of x1 is equal to 0, x2 is equal to 0, x3 is equal to 0. Like, let's say we don't have a tau, but we only have 3 variables, then there will always be a trivial solution of the problem, which means that we can just take x1 is equal to 0, x2 is equal to 0, and x3 is equal to 0. I hope this is clear. If not, it will become clear in a second. So when we take, let's just start with taking 4 variables: diameter, viscosity, rho density, and tau. Now we'll set one of them equal to 1. Let us just set x1 equal to 1. This is again arbitrary. This is not trying to lose any generality. You can put x2 equal to 1 or x3 equal to 1. We'll just put x1 equal to 1. And then we will uh, take this in form of like dimensions. So n1 is the dimensionless number, has dimensions 1. Uh, Dimensions of d is L. We have found this dimension here. L raised power of x1. Mu d is ml minus 1, t minus 1 raised power of x2. Rho d is ml minus 3 raised power of x3. And tau is ml minus 1, t minus 2 raised power of x4. Now I can expand this more, and I can write this as L raised power of so you can collect all the powers from all the variables of L. This is x1. There is minus 1 into x2 minus x2 minus 3x3 minus x4, right? Then I have m with x2 plus x3 plus x4, and then I have t, and the powers are minus x2 minus 2x4, right? Now I want to have the final solution such that the dimensions of n1 is unity. So all these powers of L, M, and L, M, and T have to go to 0, or x1 minus x2 minus 3x3 minus x4 equal to 0, x2 plus x3 plus x4 equal to 0, and minus x2 minus 2x4 equal to 0. And note that x1 is actually equal to 1 because we have assumed that. So I can just write here x1 equal to 1, right? So I have now 3 equations and 3 variables, and it's pretty easy to solve them. I encourage you to go and solve them. I will just give you the answers right away. So the answers we get is x2 equal to minus 1, x3 equal to half, and x4 equal to half. Now what I was trying to tell you before is, let's say you did not choose 4 variables, you chose 3 variables, right? You chose 3. So why did we choose here 4 variables? Because we wanted to have all the dimensions, plus we wanted to set one of them equal to some value, where we set x1 equal to 1. You can put x1 equal to minus 1, or you can put x2 into anything. But let's say you only chose 3 variables, because we know we'll get 3 equations. So you chose 3 variables and you did not put any value of x1. So you chose mu d, rho d, and d. Now you chose these 3 values and you did not have tau, and you did not put any value of x1. Then x1 equal to 0, x2 equal to 0, x3 equal to 0 will always be a trivial solution. So that is why we do not want to have 3 variables. We always want to have 4 variables, such that they span all the dimensions, and then we want to put one of the values to be non-zero, so that you get some solution in the form. I hope this is clear. If not, then please feel free to contact me with any questions. But now we solved this. We basically used x1 equal to 1, we got x2 equal to minus 1, x is equal to half, x4 is equal to half. And you can put these values here and satisfy that this will actually be, this will come out to be correct. So let me find the final value of n1. So the n1 is d raised power of x1, which is 1, d, and mu d says, which is x raised power of 2, is minus 1, mu d, and x3 and x4 are half each, which means square root of rho d into tau. So this is the value we got for our first dimensionless number, d into rho d tau mu d by mu d. Can we check whether these dimensions are 1 or not? Yes, we can certainly do that. We can just write here as L, then square root of ml minus 3, and then tau was ml minus 1 t minus 2. Let me just check once. Yes, ml minus 1 t minus 2, and then the denominator is ml minus 1 t minus 1. So if you check, you can check this will become actually ml minus 1 t minus 1 in the numerator also, and thus this dimension is actually equal to 1. So yes, n1 is dimensionless, and it actually uses the variables we wanted to use. So now we have gotten the first dimension. We have to find another dimension because according to our system, we'll have two independent dimensionless numbers. So let's start by finding the second dimensionless number. Let me use another color for this, n2. Now we have to again use four variables, as I said, and then put one of the powers to be 1. So we have to choose different ones now because we have already used 1, 2, 3, 4. Let's just skip the fourth and use fifth one. So 1, 2, 3, 5. Right? That's something we can easily do. So let's use 1, 2, 3, 5. So we will use d raised power of y1, mu d raised power of y2, uh, rho d raised power of y3, and then gamma raised power of y4. Okay. Sorry, just let me erase this in case there is any confusion. Gamma raised power of y4. Now again we can put y1 equal to 1. You can put y2 equal to 1. There is no loss of generality. You will just get some dimensionless number with different powers. So you may get n2 prime, which is some form of exponent form of n2, so which are dependent on each other. So you can put any of these to be 1 or 2 or 3, whatever you want. We are not doing any generality. So uh, just like we'll put one of them equal to 1, and to be simplest we just used y1 equal to 1. Now let me just again put very quickly now, because we have done this before. I will just write down the powers. We want this to be 1. We want this L raised power of y1 is 1, ml minus 1 t minus 1 raised power of y2, rho d is ml minus 3 raised power of y3, and then gamma is mt minus 2 raised power of y4. Your equations this time would become something like this: 1 minus y2 minus 3 y3 equal to 0. This would be for L. For M, you will get y2 plus y3 plus y4 equal to 0. And for T, you will get y2 plus 2y4 equal to 0. Again, this is not difficult. I'm just combining all the powers of L1 minus 3y3 and minus y2, and then equating them equal to 0 because the power of 1 is 0. So this is something we have done. And I'm just writing the equations for all the three dimensions down. Again, you can solve this. I will not be spending time in solving this for you, but this is not difficult. You can solve this yourself. And you will get that y2 equal to minus 2, y3 equal to 1, and y4 equal to 1. So our number n2 can actually be seen very easily. Sorry, this is y4 equal to 1. My mistake. Y4 equal to 1. So n2 can be quickly found to be d mu d gamma by mu, uh, sorry, again, this is d rho d gamma because we have mu d is minus 2, so the power of mu d will be in the denominator square, so d rho d gamma by mu d square, right? So this is our n2. Now the first thing we should note is that n2 and n1 are not related, because this has gamma and this doesn't have gamma, so they are not. I cannot say that n2 is n1 square or n1 cube. They are different, clearly different from each other, and I cannot say that they are independent from each other, because they have different variables, right? So first, that you can check for yourself that n2 has dimensions of unity. You can check that yourself, verify yourself, that like we did for n1, right? Now we got two dimensionless numbers, but somebody might say, oh, why did he, just to clarify, why did he put y1 equal to 1? Why can't he put y2 equal to 1? So let me just write down the for just to be clear, if we use y2 equal to 1, you can try the whole thing out like I have done here. Please do that. That will be a good exercise for you. And you can find n2 prime, which is something similar to n2. You will find that that will come out to be mu d raised by d rho d gamma. You can try that out, and you will find that if you use y equal to 1, this is the solution you will get. And these n2 prime and n2 are dependent on each other, so we can only use one of them, because n2 prime is actually uh, 1 by square root of n2. So if I do this, then actually I will get n2. So we cannot use, we can only use one, either n2 or n2 prime. So we can choose whichever we want. But basically I wanted to clarify here that the dimensionless numbers have to be independent. So I hope this is clear, that how we use Rayleigh analysis to find dimensionless numbers. So what we did was, we had 5 physical quantities. We wrote their units and dimensions. We said that there are 3 dimensions: mass, length, and time. There will be 2 dimensionless groups. Then we said we will use 4 variables always, and then put one of the powers to be 1 in Rayleigh analysis, and then solve the whole problem to find the value of dimensionless groups, like by equating the powers of mass, length, and time to be 0. And we did this twice. Now let's just, for to be complete, let us do this one more time. I just want to show you something more interesting. Let us say we have n3, and you said, oh, I want to use another set, because there are 5 variables. You can choose any 4 variables, because you just want to make sure that you're spanning all mass, length, and time. And let's say you decided to now choose d mu d tau and gamma. You did not want to use density now, so you started with d raised power of uh, c1, uh, mu d raised power of z2, uh, tau raised power of z3, and gamma raised power of z4. You can do this too. This is also allowed. And then you can put z1 equal to 1. Again, you can use something else also, but let's just put z1 equal to 1. And your equations will become length raised power of 1, ml minus 1, t minus 1 raised power of z2. Tau is ml t minus 2, sorry, ml minus 1 t minus 2 z3, and mt minus 2 z4. So the equations now will become 1 minus z2 minus z3 equal to 0. This is for length. For mass, it will be z2 plus z3 plus z4 equal to 0. And for time, this will be minus z2 minus 2 z3 minus 2z4 equal to 0. So you can again solve this yourself, and uh, you can find that z3, which is the sorry, z2, which is the power for viscosity, comes out to be 0. Z3 comes out to be 1, and z4 comes out to be minus 1. In other words, we are saying that n3 is actually equal to d into tau by gamma, and you can verify that. This is quite straightforward for you to verify. This is what you are getting, and you can again verify that this is dimensionless. Now my question to you is that, let's say we have n1 here, uh, we had n1 here, this one, and n2 again written. So let me just write down here for you to see clearly. We have this as n2 we had d into mu d, sorry, we had rho d gamma by mu d square, gamma by mu d square, right? And n1 was d into rho d tau by mu d. Now the question I have is, are these numbers independent? So the Buckingham PI theorem told us that there will be only two dimensionless numbers that will be independent. So now, are these numbers independent, or are these numbers dependent? So can you somehow find that there is a relation between n2, n1, and n3? Uh, and I mean, I will just very quickly show you that there is a relation, and you can verify for yourself that actually n3 is n1 square, n1 square times n by n2. Yes, you can verify this for yourself that n3 is n1 square by n2. Uh, Let me just make sure that this is true. So if we have n1 square, that will be d square tau into rho d by mu d square, right? And then n2 would be d into rho d into gamma by mu d square, and then this goes away. Rho d also goes away, and this is nothing but d into tau by gamma, right? So we can see that n3 is dependent on n1 and n2, and hence it is not independent, and thus we can only use two dimensionless number, and that clarifies the importance of Buckingham PI theorem. So we do not have to do this exercise more than we need to. We only need to do 2 times, and we can find the right dimensionless numbers. So I hope this video was useful. We'll be happy to take any feedback, and please feel free to ask any questions that you may have. Thank you.